Lesson 11.1 is about the areas of rectangles. The formula for the area of a rectangle is base times height. And it doesn't matter which is the base and which is the height. One dimension times the other. We can think of it as also length times width. So as the rectangle is sitting here, I would call the base maybe the length across the bottom. And the height is always measured perpendicular to the base. So that's the other side. In a square, because square is a type of rectangle, base times height would be side times side, which are the same. So for a square, we can say that the area is equal to side squared. Okay, and then two theorems to go along with the area of a rectangle formula is the first one is that if two figures are congruent, it means they have the same area, and vice versa. And then the second one is that the area of any region, interior region of a polygon, is the sum of its non-overlapping parts. And what this allows us to do is to take a big region and to subdivide it into smaller parts and find the area of the smaller parts, if that's easier, and add them up to get the total area of the region. So first, as a little warm-up, if we were given certain bases and heights, or areas and heights, or areas and bases, just finding what the missing attribute would be. So as an example, if I have a base in this first column, a base of 12, and a height of 5 of a figure, of a rectangle, then my area is 12 times 5, or 60, and that, remember, is going to be in square units, 60 square units, whereas the base and height are linear measurements. If I have an area of 120 and a height of 8, means my base is just going to be 120 divided by 8, or a linear 15 units. If I have a base of 3 root 2 and a height of 4 root 2, I multiply together 3 root 2 times 4 root 2, which is 3 times 4 times root 2 times root 2. So 3 times 4 times 2, which is 24. And if I have a base of 2x and a height of x, I multiply together a base of 2x and a height of x minus 3. I multiply those dimensions together, and I get an area of 2x squared minus 6x. Okay, so let's say that I have to figure out the area of this region, and this is using that theorem that the area of a region is the sum of its non-overlapping parts. Well, it just means we can carve this up, and I can carve this vertically or horizontally into separate little rectangles and find out the area of each of the rectangles pretty easily, and then add those up. So if I look at this, across the bottom, if I want to know the length of this, first of all, this bottom horizontal rectangle, I notice that across the bottom I have length of 3 if I look up above to here, and then another 3, and a 3, and a 3. So I really have across the bottom, I have a base that is 12 long and a height of 2. So that's 2 times 12, or 24 square units. And then the next rectangle, I have 3, 6, 9 in length and a height of 2. So this is 2 times 9, or 18 square units. And the next rectangle, I have 3 and 3. So I have a length or a base of 6 and a height of 2. So this is 2 times 6, or 12 square units. And then the top is I have a, looks like, oh, I'm missing a part here. This should be a 2. I have a 2 by 3 square, or not 2 by 3 rectangle. So that is 2 times 3, or a 6. So I can add up all of these little areas, and I have 30 plus 30. I have 60 square units, whatever units I'm dealing with, of area of that total figure. All right, one last example of taking a figure and carving it up. I'm going to divide this into some smaller rectangles. So if I take a dashed line segment across here, I have a little rectangle sitting at the top. And if I want to make this one here, the big one in the, sort of in the middle there, into one rectangle, I can do this. And then I've really got this divided into 3 rectangular pieces. So this piece here up at the top is 4x by 2x, so 4x times 2x, or 8x squared in area. And the big rectangle is 8 on the base and a height of 3, so 8x times 3x, or 24x squared. And then this little one that I have over to the side here is x by 2x, so that is 2x squared. So altogether, if I add up 8x squared and 2x squared and 24x squared, I have a total area of that figure of 34x squared. So that's it, dealing with areas of rectangles, a very simple concept.